Hello, I'm David Bernard, the Product Manager for X-Ray Systems for Nordson DAge, and it's my great pleasure to introduce you to X-Plane. This is our new and patent applied for option for X-ray inspection systems, which offers a revolutionary method for non-destructively inspecting inside printed circuit board assemblies and electronic components. This option is available in addition to all the excellent inspection capabilities that Nordson DAge X-ray systems already provide as standard. Here is a 2D X-ray view of a complicated double-sided printed circuit board, which is difficult to interpret and analyse as the joints from both sides of the board overlap each other. Using X-Plane allows you to simply and easily separate the different layers within the board. In this example, here is the plane of the QFP on the first side of the board, and here, quite distinctly, are the two T-SOPs on the second side of the board. As Nordson DAge focuses exclusively on the X-ray inspection needs of the electronics industry, we have developed the X-Plane technology to satisfy our customers' emerging challenges to their necessary inspection tasks, especially as they must deal with typically double-sided, multi-level boards which have increased complexity and ever-shrinking component and feature sizes. X-Plane is the latest in a long line of successful innovations in which Nordson DAge has provided leadership to the electronics industry. These innovations have included the unique sealed transmissive X-ray tube that offers a true submicron feature recognition at up to 10 watts of power, and a whole new range of X-ray systems that feature our exclusive radiation resistant flat panel detectors. X-Plane provides users of our X-ray systems with the ability to make 2D X-ray views in any plane of a printed circuit board assembly or other sample without the need to cut or destroy the item. X-Plane uses a proprietary, patent applied for tomosynthesis technique, so should therefore not be confused with the more limited imaging technique of laminography. X-Plane creates a series of 2D X-ray slices through any plane in a user-defined area of a printed circuit board. The operator is then quickly and easily able to view and analyse these 2D slices from top to bottom, front to back, left to right, and any plane in between within the defined area. X-Plane can be used anywhere in an 18 by 16 inch or 457 by 406 mm inspection area, and will even work with high magnification views. It is available on Nordson DAge flat panel detector and image intensifier based diamond and ruby X-ray systems. All of this is possible without needing to cut the board. X-Plane provides enhanced inspection capabilities for many of the most challenging applications in the electronics industry. It can be used to investigate the position and size of voids at joint interfaces and other critical locations in BGAs, CSPs, QFNs and LGAs, amongst others. It can be used to identify head-on pillow defects and open joints in BGAs. It allows the separation and inspection of the different layers within a package-on-package device or multi-chip module, where otherwise different connection layers would obscure each other in the standard 2D X-ray image view. X-Plane will also assist in the similar situation that exists when an obscuring detail from the second side of the board in the standard 2D image needs to be removed to prevent confusion and enable the best possible analysis. But that's not all. There are many more applications in which X-Plane will assist. For example, it will help investigate the quality and fill of through-hole joints and vias, as well as indicate if components are tilted on a board or if there is board warpage. The challenge of inspecting the joint quality and other features in complex connectors will also benefit from X-Plane analysis. It will also provide the opportunity to examine the tracks at each individual board layer, amongst many other applications. The X-Plane technology uses standard Nordson DAge X-ray systems and has only become possible through our extensive X-ray development programs into X-ray tubes, detectors and software. This means that X-Plane will work anywhere within an 18 by 16 inch inspection area and can be used even at high magnification to allow analytical focus on the smallest features. X-Plane operation is very simple. The sample is loaded into the X-ray system and the operator defines the desired region of interest within the sample. A series of 2D X-ray images is then taken 360 degrees around the region of interest, as can be seen in this movie clip of an X-plane scan. In this example, a DAge radiation-resistant flat panel detector is being used to capture the images. Excellent results for X-plane can be achieved with DAge flat panel detectors or image intensifiers. Our flat panel detector will offer lower image noise and more grayscale contrast in each image compared to using an image intensifier. But the choice of which will be best must be considered in light of the whole range of inspection tasks that your X-ray system will need to satisfy. Therefore, the best detector choice will need to be discussed with your local DAge representative, who will be able to advise you as to which we would recommend based on your specific needs. Whichever detector is chosen, it typically only takes a few minutes to acquire all the images needed for X-plane analysis. Once all the images, or projections as they're sometimes called, have been acquired, a proprietary, patent-applied for tomographic or CT reconstruction is made from the data using the standard X-ray system control PC. This produces a virtual 3D or CT model of the defined inspection area. This model can then be quickly, simply and easily sliced in any plane using the included X-plane viewer. The reconstruction process only takes a few minutes. Within the X-plane viewer, the reconstructed 2D slice images can be saved and the movie clips produced to allow the best presentation of the results. The whole 3D model can also be exported as a stack of reconstructed 2D images. This dataset can easily be imported into an external full CT visualization software package to allow additional analysis, model manipulation and measurements, as well as to create three-dimensional rendered images. A full CT visualization package can be supplied by DAge upon request. I hope that I have now given you a brief introduction to our X-plane technology, but now I want to concentrate on showing you some examples of X-plane that I believe will be relevant to your inspection needs. Ultimately, however, you will need to try your own samples with X-plane to see what it can offer you, and your local DAge representative will be happy to arrange this. This is particularly important to consider in order that you can see the full image quality that the X-ray system will actually provide. The first example I want to show you is how X-plane can be used on a BGA on a multi-layer circuit board. The image on the left is the standard system 2D X-ray image, where all layers in the board are seen at the same time. The image on the right is a single inverted X-plane slice through the 2D field of view, and in this case it is a slice near the mould layer of the BGA package. At this layer there is clear evidence of voiding in the mould compound, which is seen by the density differences most clearly seen in the centre of the device. These features are not easily visible in the standard 2D image. With X-plane technology we have many individual slices that we can view within the sample. The next few slides will show some of these, and they can be compared with the 2D image. In this X-plane slice we are approximately in the middle of the BGA balls. If the component were tilted following reflow, for example, then a non-uniform ball diameter might be seen across the device. This next X-plane slice is at the interface between the BGA balls and the board. The tracks can be seen at that layer only, and when you compare this image with the standard 2D view, the tracks from other layers and the discrete components on the second side are not visible. In this way, it allows uncluttered and better analysis at this crucial to joint quality layer. Continuing further into the board, we can now see one of the internal track layers. Once again, all the confusing information from other layers has been removed. Here we now have an X-plane slice at the second side of the board, as the discrete components are now clearly visible all on their own. To give a better representation of all the layers that the X-plane technology can see in this example, here is a movie clip looking in the top to bottom direction through the BGA. This was produced through the X-plane viewer. And remember, all of this was achieved without cutting the board. But X-plane is not just limited to low magnification fields of view. If more detail is required for best analysis, then X-plane can be run again using a higher magnification. In this example, I'm investigating a corner of the BGA seen previously. Again, the standard 2D view is on the left, and on the right there is an X-plane slice at the wire bond level. All other layer information has been removed from the view. As before, we can now look at different layers within the whole structure, and in this case the voiding in the mould layer is even clearer. Using a higher magnification view also allows us to see more detail within the BGA balls. In this X-plane layer, located near the solder ball to device interface, some voiding can be seen. Continuing to move through the BGA balls, this layer, somewhere in the approximate middle of the BGA balls, shows more voiding, and these voids are at different locations to that shown in the previous image. In this way, X-plane is able to identify not just the size, but also where in the BGA ball volume the voids are located. Knowing the location of voids in BGA joints is understood to be critical in understanding the long-term reliability of these joints. Here is a detailed view at the BGA to board interface layer. If required, the X-plane viewer allows the operator to digitally zoom into the CT model to help the analysis. It also allows views from other planes, not just top to bottom slices, as can be seen in this side view slice detail. In this example, the location of the void, when seen side on, is clearly visible and is not close to either joint interface. Now for another X-plane example. This time it is of some through-hole joints in a connector. An optical image of the sample is shown below the standard 2D X-ray image. The X-plane slices separating the two board layers are seen on the right. Here are some side view X-plane slices of the through-hole joints. The partial level of solder fill in the left-hand connection is clearly seen when compared to the complete fill of the other joint. Again, these images were all achieved without needing to cut the board. And here is a movie clip looking through the side of the connections, and this allows observation of any voiding or incomplete fill very easily. And now we also see the same view looking top to bottom through the device. This is an X-plane movie looking through a QFN. The 2D image shows substantial joint shape variation on the left-hand connection compared to those on the right-hand side. This has been caused by a tilting of the device during reflow, making the right-hand solder joints flat and elongated, and those on the left-hand side tall and narrow. This is reflected in the layers shown in the movie clip, as well as the separation of the pads from the second side of the board. X-plane will provide a particular benefit for the investigation of package-on-package or POP devices, where the multiple levels of solder ball interconnects often obscure each other in the standard 2D X-ray image, as can be seen in this example. Furthermore, even if an oblique angled view X-ray image is taken, the very low aspect ratio of these package types may not allow suitable separation of one layer from another for best analysis. In this example, an X-plane scan has been taken, and the X-plane slice shown is of the solder balls connecting to the board. The misalignment of the package, a missing solder ball, and a solder bridge can all be clearly seen, and all without needing to cut the board. Now we can continue to look inside the different layers within this very thin, complex device and separate the various layers in the middle of the device, that in the standard 2D view all appear to be at the same level. Now we show an X-plane slice at the second level package of the solder balls without the lower level solder balls interfering with the view. And then continuing on through the device, here is a video top to bottom through the whole package-on-package device. As before, if we require more detail, then we can make an X-plane scan at higher magnification. The voiding within the lower BGA ball layer is now much clearer. So I hope I've been able to give you an introduction to DAge's revolutionary new X-ray inspection option, X-Plane, that is available on all our new Diamond Flat Panel, Diamond, Ruby Flat Panel and Ruby X-ray systems. And what does all this cost? Well, please contact your local DAge X-ray representative who will be happy to tell you and arrange for a demonstration so you can see what X-Plane can offer you. Your nearest DAge office or representative can easily be found by going to the DAge website at www.nordsondage.com. Thank you for your attention.